This is our next notes in algebra, radical expressions, and our last lesson we looked at exponents or numbers with exponents that are fractions. And if you remember, that meant that according to the fraction and how it went, it would either be a square root, a cube root, and then there might also be a power associated with it. Now we're going to look at these expressions and see what we can do with them. So we first 7.3 we looked at, well, what are the basics of a rational expression, and now what can we now do with these radical expressions. So an example of a radical expression would be something like the square root of 80 or the square root of 25, right? And this one in the end would be 5, right? This one we'd have to do something with. We could get a decimal, but there's some different things we can also do with it to make it a little bit easier. Okay, so we're going to look at some of these important rules, okay, and then practice some in your notes. I don't think I'm going to show you every single rule because there's quite a few rules, and I think you can become overwhelmed with it. So I'm just going to show you a few here. Add these to your notes. We'll practice these in class, and then we'll add a few more. Okay, so the first one is the product property or rule. Okay, this says if you have something like the square root of AB, that's also equal to the square root of A and the square root of B. So if we have a number in here, we can divide it up, okay, and make its factors, and then square root for some factors that we know are perfect squares or perfect cubes, wherever they are, and then we can reduce this radical under here to something more meaningful. Okay, so let's look at an example. So the first one here is we have the square root of 36. Now we could also just say this is 6, right? We know that 6 times 6 is 36. But a different way to look at this, we could also say we could divide this up. So 36 is equal to the square root of 9 times the square root of 4. Okay? And then we would know the square root of 9 is equal to 3, and the square root of 4 is equal to 2, and 3 times 2 is 6. Okay? That's a simple one. Really, we could have just made it 6 at the beginning, just to show you how it works and something that's easy to see. Well, how about let's look at something a little different. 80 does not have a perfect square. We could go like 8 times 8 is 64. 9 times 9 is 81. It's not in there. So what can we do with this? So we kind of mess around with it. You might be able to guess right away what to do. We know some perfect squares like 4, and we know some perfect squares like what would it be? 16 is a good one. 25 is a good one. 36 is a good one. So we kind of want to look at 80 and see if we can come up with some obvious ones. Okay, so 4, right? 4 is a good one. So 4 times 20 would give us something good, right? And we made that a little bit long now. Let me make that smaller. So if we had this one, right? 4 times 20, we could then say the square root of 4 times the square root of 20. We could then make that 2 times the square root of 20, right? Then looking at 20, we could then say 20 could also be the square root of 5 times 4. Again, we have another 2, so the square root, this would be 2. We put this together, so we'd have really 2 times the square root of 5, and then we'd have this other 2 from this 4. So 2 times 2 times the square root of 5, and this would be 4 square root of 5. So we can take out factors from this number, this radical, or radicand, I'm sorry is what it's called, and take ones out that we like, that are perfect squares, and then take them outside of that symbol, and make this a little bit easier to manage. Okay, so that's the product property. We can take out, we can reduce this 80 to its factors. And really, at the beginning, we could have just went 4 times 4 times 5, because we know 20 is not a good one either. We should try to find as many as possible when we do that. There's lots of different ways to do these as well. But that's one example of a product property. If we look at another one, multiplying square roots, okay, so we could, when we're multiplying square roots, we could just take the one square root times the square root of the other. Okay, that's not going to help us very much. If we take square root of 2 times the square root of 14, if that gives us the square root of 28. What might help us is if we took this square root, multiplied it by the same square root, and then we would have, the square root of 2 squared, and it would be 2, right? So that's kind of what we're going to do. We're going to 2 square root of 2 times the square root of 2 times square root of 7, right? Because the square root of 2 times the square root of 7 is the square root of 14. So that's good. Now we have these two together, square root of 2 times the square root of 2. That becomes 2, and we're left with square root of 7, and we can't go any further with that. So we can use this fact that we can multiply these together to get the new square root, and we can also use the one we just learned about really we can take the square root of 14 and make it 2 times 7, and then use these two together to take something out underneath that square root symbol. Okay. Let's look at another example. So how about variables? So how does this idea work with variables? Okay, so 90. So what can we do to 90? Let's see here. 9's a good one, right? So we could go square root of 9 times, and then we'd be left with 10, right? So we could do square root of 5. Let's see, we got 10 left. So yeah, we're kind of left with 5 times square root of 2. And that's not really going to help us. So we're just going to go with square root of 10. Okay, this will help us a little bit. And then, look, we can do, we're going to times that by the square root of x squared, right, times x. And then we're going to do, this would actually be square root of y times square root of y. And then we'll do 7 squared times, not 7, z squared times z squared times z to the first, right? So then, so we take, now we go back and look and see what we have. So square root of 9 we know is 3. And this one's going to stay under here, square root of 10. And then, actually, I'll wait for that. Let's take the ones out we know first. So this one we got. Then x squared is going to be x, right? And then x is going to stay underneath. Let's get rid of that one. And then we have these 2y squared, or y to the fourth. But we know y squared times y squared is y to the fourth. So we can just really make these into y squared. Then we have 2z squared, which is really z to the fourth. We can just take them out because their square root would be z squared. And then they're canceled. The only thing we're left with is z, x, and 10. And then we do the square root of that, 10 x z. And then that one would be reduced as far as we can. So then we'll look at the last one here, the last row we're going to look for now. And there's a few more. We'll do some of those in class, perhaps. So we can also, so we have a quotient under here, and we really can't have that. One of the rules is you can't have this. You have to do something with it. Okay. So what we can do here is we can realize that this is equal to the square root of 35 over the square root of 15. Okay. And then we have to think, so what can we do with these to make them, something we can use, right? So what we can do is actually reduce these, and I think I jumped the gun here a little bit. I don't really want to go here yet. What I really want to do is reduce this first. Okay, so I'm going to white this out here. There's a lot of white out this time. So I'm going to reduce this by taking 15 into 35. We're taking something that's a common factor, and we can do that. So if we did 5, we'd end up with the square root of 7 over the square root of 3. Okay, so that gets us a little bit better. So we can reduce when we're doing these. And then we can turn this into what I did, square root of 7 before, and the square root of 3. And what we want to do is we want to get rid of this fraction under here. So we either have to get rid of the 7 or the 3, and we'll get rid of the 3. What we'll do is we'll multiply both sides by the square root of 3. And so then we would have square root of 7 times the square root of 3 would be equal to 21. And then the square root of 21. And then this would be square root of 3 times the square root of 3 would be 3. And now we've gotten rid of that fraction underneath the radical sign, the square root sign. And now we have square root of 21 divided by 3, and that's good. So that's some examples of how to do these with quotients, with when they have variables, when we're multiplying square roots, and also the product rule as well. So add this to your notebook, and I'll see you in class.